All right, so the idea with medians is you're going to find the midpoint on each side and then draw a line from that midpoint to a vertice. So for instance, if we wanted to find the midpoint of this side, we'd take out our ruler and we would find how long this is, and it looks like it's about 1 inch, so about a 1/2 inch right here would be the midpoint. And then from there, we would connect that to the opposite vertice. So from there to there, and that would be our median. And what's special about the median, after I draw it really quickly, is that it splits this into 2 equal parts by definition, because that's what a median is. It is the midpoint connected to a vertice. So I can do that for all the midpoints on each side and all the vertices on each side. So if I look at this right here, from here to here looks to be about 2 1/4. So if I cut that in half, that's going to be 1 1/8, which would be about right here. So that's the midpoint there. And then from there, I can connect that to the opposite vertice, which is this one. So if I connect those guys in a line, I should get something like this. And again, that will split that into 2 equal parts right there. And you can see where they intersect. The next one I'll do in blue should be the midpoint from this side, the longest side, which is about 3 inches long, which means about 1 1/2 is where we're sitting, so about right there. And that'll split that into two equal segments. And then from there to this median, or I'm sorry, this vertex, we'll create a median that also intersects in that same spot. So the intersection of these 3 medians is right here. And the intersection of that we call either a Medicenter, because median, or a centroid. And what's cool about the centroid or Medicenter is that that point right there is the balance point, the center of mass. So if you can imagine like taking a pencil or a pen and trying to balance it on your finger, now you might realize that it's going to be somewhere in the middle for this guy, directly in the middle, because this is essentially a straight line. Which is basically the midpoint. This end's a little bit heavier, so it's a little bit tilted to the left. But if you were to take this triangle and try to balance it, and everything was equal, like it was a piece of paper or something, that would be the point you'd want to place your finger to balance everything. So knowing that, no matter what triangle we have, whether it's acute, obtuse, right, or whatever, the Medicenter or the centroid is always going to be somewhere inside the triangle, because you would never try to balance something, like you wouldn't think the balance point for this guy right here was somewhere over here, right? It has to be somewhere on this object for it to balance. So the medians are always going to intersect at a point that we call a Medicenter or a centroid, and it's always going to be inside the triangle somewhere. So let me show you another example with acute triangles. So once again, in order to find the Medicenter or centroid, we need to find the median of each side. So I'm going to measure from here to here, and that looks to be about 1 1/4, which means if we're to divide that in half, we're going to get about what, right here it looks like. So there's the midpoint there. And if I was to do that for another side, maybe here, to be right in the middle right there, cutting that into 2 equal spots, or 2 equal segments. And then also, what color did I not use? I didn't use red. If I were to cut this in half, that looks to be about 1 1/4 as well. So we're talking about right here-ish for the midpoint. And I'll cut that into 2 equal segments. If we were to connect those to their opposite vertices, which I will do really quickly from here to here, you would notice that all of those medians, those lines that I'm drawing that connect the midpoint to a vertex, all intersect inside the triangle at a single point. So that point right there, this point here, is the Medicenter or centroid of this triangle. And because this triangle appears to be isosceles, I think this side and this side are both the same, you can notice that this guy's a little more centralized than this might be, right? Than this guy up here. This guy is kind of tilted more towards down the bottom than up at the top, whereas this guy seems to be pretty much in the center of the triangle if we were to think of the center being the center of a circle, which we'll talk about for a different type of center. If we look at a right triangle, same idea holds true. We cut this in half, and this one looks to be about 1.5. So if we cut that in half, it's about here. If we were to draw from that midpoint to this vertice, we'd get this. For our median, over here it looks to be about 2. So at 1 is about halfway, and if we connect that to its opposite vertice, we get a median like that. And our last midpoint and median will be here. That's about 2.5, so about 1. And here, maybe right there is our halfway point. So if I connect that to my vertice, that was at 1.25, we get there. So the intersection of all three medians results in the Medicenter, or the centroid. And what's cool about these, again, is since they are medians, the idea is that they are from the midpoint of a side to a vertice, so it cuts this side in half. Same thing over here. And it'll always be in the center because that is, or always be inside the triangle because it is our center of mass. So the balancing point for any of these triangles. So that's it for the Medicenter and centroid. I'll make separate videos for the different types of centers of a triangle and then also do some example problems separately.